Hello students, I'm Professor Sameer Sabharwal and this is my lecture number 26, chapter Atomic Structure, and in this lecture I'm going to discuss electronic configuration of elements in their ground state. In my previous lecture I gave you information regarding various rules for filling of electrons in orbitals, that is Hund's rule and Aufbau's principle. Now we are going to get a complete information about those laws by filling orbitals. So let us start with the first element, that is hydrogen. If I start with atomic number 1, obviously that element is hydrogen. Now basic thing is that we know that according to quantum model we have an atom. In atom we have subshells. In subshells we have orbitals and electrons are present in orbitals. So we discuss quantum numbers just to differentiate orbitals. As we know that there are 4 quantum numbers. Why do we need 4 quantum numbers? I mean to say, if I write first quantum number, that gives me information about shell. If I write second quantum number in addition to first, that gives me information about subshells. And if I write a third quantum number in addition to first and second, that gives me information about orbital. And if I mention all quantum numbers, that gives us information about particular electron in that orbital. So this is a very interesting information. Now let us start with the first. First is hydrogen. So if I say that hydrogen in the ground state, electron is present in the first shell. In first shell we have only one orbital, that is 1s. It means electron is present in 1s. So it is better to write it like 1s1. This is shell number, this is subshell, and since it is spherically symmetric, that is orbital, it has only one orientation. So this is 1s1. Now in case of atomic number 2, this is helium. So one orbital can accommodate 2 electrons. So I preferably call this as 1s2. I have drawn energy level diagram for multi-electron system here just to clarify this. So let me put energy axis over here. Right, now you see if n is 1, right, means atomic number 1 element hydrogen. So from this diagram it is very clear the first electron is here, and we mention the first electron with clockwise spin. It is general sign convention. Okay, and for helium, how will you present this? For helium this is written as 1s2. Very simple. Now when we reach atomic number 3, this is lithium. There are 3 electrons. 2 are already filled. This shell is complete because first shell can accommodate 2 electrons. So I have to move to second shell. When I move to second shell, if it is clear that in second shell we have 2 subshells, you can see 2s and 2p. Now out of these 2 subshells, which subshell is going to be filled first? That is a problem. So we apply Aufbau's principle, which says in the ground state subshells oblique atomic orbitals are filled in the order of their increasing energies. तो वो आप यहाँ भी अप्लाई कर सकते थे कि to which shell first electron goes first. Why? Because इसके लिए एनर्जी मिनिमम है and energy in case of multi-electron system is given by n plus L value. I repeat, in case of multi-electron system, energy is given by n plus L value, and in case of single electron system, energy is given by n only. So if I count its value for 1s, this is coming out to be, you can calculate here, 1. For 2s this is 2, 3s this is 3, 4s this is 4, 5s this is 5, and for 2p the 2 plus 1 is 3, 3 plus 1 4, 4 plus 1 5, 5 plus 1 6, 3 plus d, for dl is 2, 5, 4 plus 2 6, 5 plus 2 7, for fl is 3, so this is 7, 5 plus 3 8, and g, 5 plus g 4, 9, right? For f, I repeat it here, L is 0, L is 1, L is 2, L is 3, L is 4. 0 means S, 1 means P, 2 means D, 3 means F, 4 means G. So 5 plus 4, this is 9. So if you see, after filling, which orbital will come? I mention it here, 1s, obviously 2s, because n plus L for 2s is 2. So for lithium, the configuration comes out to be 1s1, 1s2, 2s1. Very simple. So I shift the third electron here with the clockwise spin. Then beryllium, now number is 4. Again, very easy. You have to fill orbital whose energy is lower. This is Aufbau's principle. After filling it, because an orbital can accommodate 2 electrons, or 2s is completely filled, definitely the next electron moves to 2p subshell. So I can mention this to be S. Now for atomic number 5, boron, we can write it to be 1s2, 2s2, 2p. Sometimes we mention electron in a subshell. Remember, 2p is a subshell. Okay, when, as I have mentioned, when we write 2 quantum numbers, that represents subshell. If I write third quantum number, that is here x, y, z, that represents orbital. Now, first of all, analyze. This is 2px, 2py, 2pz. Do they have same values? In case of multi-electron system, relative energy is given by n plus L value. So we do not consider the third quantum number. Means they have same energy. So those orbitals having same energy are known as degenerate orbitals. They are having approximately same energy. So after boron, we are filling boron. So in case of boron, there are 5 electrons. So electron will go to p subshell. Since all subshells have same energy, we can assign electron to any orbital of 2p subshell. Okay, fine. Now next is 6, carbon. Yeah, this is again an interesting question, because we need to follow a rule to fill this configuration. Yes, this is 2px1. The question comes, is it going to px or moving to next orbital of same energy? For this, we should know Hund's rule. That rule says, Hund's rule of maximum multiplicity. That rule says electron pairing will not occur unless each orbital of approximately same energy contains single electron with the same spin. तो इस प्रिंसिपल के अकॉर्डिंगली जिन ऑर्बिटल्स की एनर्जी अप्रॉक्सीमेटली सेम है उनमें सबसे पहले एक एक इलेक्ट्रॉन विद सेम स्पिन आएगा, उसके बाद उसकी पेयरिंग होगी। तो इसीलिए जो कार्बन था दैट वाज सी दिस, एंड इन केस बोरोन था वो ये था, एंड इन केस ऑफ कार्बन configuration will come out to be 2px1 2py1 instead of 2px2. So carbon is written as 2px1 2py1. A very interesting thing. This is Hund's rule. अब आप समझ रहे हैं कि जो रूल हम याद करते हैं वो अप्लाई करने पे कैसे समझ में आ जाते हैं. Then comes nitrogen. If I take nitrogen, right, थोड़ा इसको लाइन में लिख देते. This is carbon, this is nitrogen. Yeah, 7. 1s2, 2s2, 2px1, 2py1, and 2pz1. So now you can see that all p orbitals of 2p subshell are singly filled. We say this is Hund's rule of maximum multiplicity. Maximum multiplicity means maximum spin. If you count the spin, clockwise spin is represented by 1 by 2. For 3 unpaired electrons, total spin is plus 1 by 2, plus 1 by 2, plus 1 by 2. This is equal to 3 by 2. Or if we do pairing, right? If we do filling like this, now count its spin, plus 1 by 2, anti-clockwise is represented by minus 1 by 2, plus 1 by 2. This is coming out to be plus 1 by 2 only. So this is maximum multiplicity, means maximum spin, and because of orbitals, because of single electron in orbitals of same energy, the repulsions, they are in different directions, so repulsions is minimum. So this is for stability of an atom. So orbitals of approximately same energies are filled singly, right? This is Hund's rule. Now atomic number 8. This is oxygen. Yeah, we start pairing now. 2s2, 2px2, 2py1, 2pz1. Is that right? उसको हम बाद में fill करते हैं. Fluorine. 1s2, 2s2, 2px2, 2py2, 2pz1, and 10 is neon. This is 1s2, 2s2, 2px2, 2py2, and 2pz2. Since p subshell is completely filled, I can write it to be 1s2, 2s2, 2p6. So let us see that energy level diagram. Here it is 2 plus 2 4 plus 3 7. Here it is representing nitrogen. If I want to write it for oxygen, this is 1s2, 2s2, 2px2, 2py1, 2pz1. Right? There are 2 unpaired electrons in case of oxygen, you can see. Right? In oxygen atom, there are 2 unpaired electrons. In case of fluorine, there is 1 unpaired electron. Please, you can see this thing. So for fluorine configuration is 1s2, 2s2, 2px2, 2py2, 2pz1, and for neon there is no unpaired electron. That p subshell is completely filled. So very interesting part. We have done electronic configuration up to atomic number 10. Now if we continue like this, we can reach up to 18 very easily. Say I move to atomic number 11, let us do it, 12, 13, 14, 15, 16, 17, 18. This is 19 and 20. Let us do it up to 20. Now symmetry is going to play its role. So that is why I remove this and put it here just to have symmetry. Fine. Now atomic number 11 is representing sodium, 12 magnesium, 13 aluminium, 14 is silicon, 15 is phosphorus, 16 is sulfur, 17 is chlorine, 18 is argon, 19 is your potassium, and 20 is your calcium. Is that clear? So we are going to do configuration up to atomic number 20. I'm going to rub this. Now you can analyze that we have filled the second shell, because second shell is a capacity of 8 electrons and we have 4 orbitals, you can count. So this shell can accommodate maximum 8 electrons. Now I will move to the third shell for sodium. How will you write it? 1s2 is filled, 2s2 2p6 is filled, and then comes 3s because of lower energy. You can see 3s, 3s1. Very simple. And the easiest way to write it, represented in the terms of noble configuration. Neon, which is representing the second complete shell, neon noble gas configuration hai. So I can write electronic configuration in terms of noble gases, neon representing 10 electrons, okay, and 3s1. Very easy way. So it is your sole discretion, mercy, right, whether to write it like 1s2 2s2 2p6 3s1 or like neon 3s1. Then magnesium. Okay, I hope so you can fill this configuration by your own. This is your sodium. Then magnesium, 1s2 2s2 2p6 3s2, or better way is neon 3s2. So my next electron goes here. Then very easy, aluminium. How will you write that? Neon, okay, just to save time, 3s2. Then comes 3p, right? Now see, 3p and 4s both are having same value of n plus l, so their n plus l value is same. Now question arises, to which subshell electron will go, 3p or 4s? So rule says if n plus l value is same, then Cn electron will move to that subshell for which value of n is less. Okay, जब 3p and 4s की टर्न आती है तो इलेक्ट्रॉन किस में जाएगा, n प्लस l दोनों का सेम है, तो इलेक्ट्रॉन उसमें जाएगा जिसमें n का वैल्यू कम है. तो क्योंकि 3p के लिए n का वैल्यू कम है इसीलिए इलेक्ट्रॉन 3p में जाएगा. सो आई राइट इट एज 3s2 3p x1, जैसे मैंने 2p सबशेल में मेंशन किया. फॉर सिलिकॉन दिस इज नियॉन 3s2 3p x1 3p y1. Fine. And for sulfur this is neon. For phosphorus, thoda space, I need some space. Let me manage some space here. Neon 3s2 3px1 3py1 and 3pz1. So this is representing phosphorus. Then comes sulfur. Neon 3s2 3px2 3py1 3pz1. Fine. Then chlorine neon, 3s2, 3px2, 3py2, 3pz1, and for argon, which is definitely a noble gas configuration, 3s2, 3px2, 3py2, 3pz2, and easiest way is neon, 3s2, because subshell is completely filled. So neon, 3s2, 3p6. So if you see this, I started from here, 3s2 के बाद जो आपकी configuration आती है aluminium, तो for aluminium 1 electron comes here, 3px1. For silicon, this is 3s2, 3px1, 3py1, outermost configuration. Phosphorus electron comes here. What is phosphorus? See, 3s2, 3px1, 3py1, 3pz1. Neon तो सबके लिए होगा ना, तो ये outermost configuration है, 3s2, 3px1, 3py1, 3pz1. And for sulfur, one more electron. This is according to Hund's rule. Then for sulfur, then for chlorine, right, 3px2, 3py2, 3pz1, and for argon, subshell is completely filled. So very easily you can understand this part and realize it कि ये जो थर्ड शेल में आपने किया है, डोंट यू फील दिस इज जस्ट रेपिटिशन ऑफ द सेकंड शेल? जो सेकंड शेल में हमने किया वही यहाँ किया है, तो कोई यहाँ समस्या नहीं आती है. यस, एक बात आपको बताना चाहता हूँ कि देखिए यहाँ नियॉन लिखा है, उसके बाद हम जो फिलिंग कर रहे हैं 3s या 3p में कर रहे हैं. जो आउटर मोस्ट शेल होती है उसको हम वैलेंस शेल कहते हैं. रिमेंबर दिस थिंग, राइट, दैट रिप्रेजेंट्स वैलेंस शेल. If it is asked how many electrons we have in the valence shell of aluminium, answer is 3. How many electrons we have in the valence shell of silicon? Now you can answer it. It is 4. There are 2 subshells, and in valence I am talking about valence shell. तो उसमें सारी subshells आती हैं. तो अब इसकी valence shell में 4 electrons आ रहे हैं. Phosphorus की valence shell में 5 इलेक्ट्रॉन आ रहे हैं. अब यहां से टर्म बनती है वेलेंसी, कि वैलेंस शेल के कितने इलेक्ट्रॉन बॉन्डिंग में पार्टिसिपेट कर रहे हैं, वो उसकी वैलेंसी बन जाती है. जैसे एल्यूमिनियम के केस में 3 इलेक्ट्रॉन पार्टिसिपेट करेंगे, क्योंकि इलेक्ट्रॉन जो वैलेंस शेल के हैं वो पार्टिसिपेट करेंगे क्योंकि उनकी एनर्जी ज़्यादा होती है, वो उसको हम वैलेंसी कहते हैं. एंड सिलिकॉन वैलेंसी इज 4. इन फॉस्फोरस वी हैव 5 इलेक्ट्रॉन्स, or in order to complete its octet, it can gain 3 electron, or it can lose 3 electron, or it can share 5 electron. तो इसकी वैलेंसी जो है वो 3 या 5 होगी. ओके, वो उसकी कंपाउंड की नेचर के हिसाब से होगा. एग्जैक्टली आप क्लोरीन को देखिए, इट नीड्स ओनली 1 इलेक्ट्रॉन टू कंप्लीट इट्स ऑक्टेट, तो इसकी वैलेंसी 1 है, पर इसकी वैलेंस शेल में इलेक्ट्रॉन्स कितने हैं? 7 है. सो दिस इज अगेन अ वेरी इंपॉर्टेंट फैक्टर. देन comes atomic number 19. ये थोड़ा गड़बड़ वाला है. If you follow the Aufbau's rule, उसको फॉलो करते हुए हमने क्या देखा? सबसे पहले 1s फिल होगा, फिर 2s फिल होगा, फिर 2p, इसमें कोई समस्या नहीं आई, फिर 3s नो प्रॉब्लम, फिर 3p नो प्रॉब्लम. Now problem arises. Now you can see in third shell we have one more subshell, that is 3d. And value is 5. Relative value of n plus l is 5. And if you see 4s, that value is 4. ऑफबॉस प्रिंसिपल को फॉलो करें. अगेन मैं ये बता रहा हूँ, ये मल्टी इलेक्ट्रॉन सिस्टम के लिए प्रॉब्लम है जहाँ इंटर इलेक्ट्रॉनिक रिपल्शंस होती है. तो इसकी एनर्जी कम है, इसका मतलब अब फिलिंग 4s की पहले होनी है. इसीलिए आई कैन राइट दिस एज आर्गन, बिकॉज ये सबशेल कंप्लीट हो गया है, राइट, 18 तक कंप्लीट हो गया है. सो दिस इज आर्गन 4s1 वेरी इंपॉर्टेंट पार्ट, यू कैन सी इट फ्रॉम हियर। अगर आप इसको एनालाइज करें तो मैंने यहां मेंशन किया है कि D इज कमिंग इन द फोर्थ शेल। सी दिस इज अ वेरी इंपॉर्टेंट पॉइंट। ये 4s का एनर्जी है, 3D का एनर्जी 4s से थोड़ा ज्यादा दिखाया गया है, दो डिफरेंस ज्यादा नहीं है, तो वी गिव इलेक्ट्रॉन टू 4s बिकॉज 4s इज हैविंग लोअर एनर्जी। So the configuration of potassium is argon 4s1, and for calcium this is argon 4s2. So we are going to fill electron here. तो ये था हमारा कितना इजीली हमने 20 एटॉमिक नंबर तक कॉन्फ़िगरेशन का फिलिंग जो है वो ऑब्जर्व किया है। अब 20 के बाद we will consider 21 to 30 which is again very important because इसमें अब D सबशेल का फिलिंग होने जा रहा है। तो इसको मैं अपने नेक्स्ट पार्ट में, नेक्स्ट लेक्चर में आपसे शेयर करने जा रहा हूँ। प्लीज़ कीप इन टच, उसको सुनिए ध्यान से, एंड डेफिनेटली इसमें और भी ज़्यादा आपको कहीं से सुनने या पढ़ने की ज़रूरत नहीं पड़ेगी। इसको ध्यान से सुनिए बिकॉज आई एम गिविंग यू आंसर्स ऑफ ऑल क्वेश्चंस हियर। थैंक यू वेरी मच।